Hello, in today's video I am going to be jumping into Blender to show off a few things from some of the animations I've been doing in here. I've been kind of just practicing with bone constraints and drivers and things like that. And I posted some stuff on Reddit recently on the Blender 3D subreddit, and I got kind of a few people actually asking how I did a few of the things in my mecha like robot leg upload. So I'm just gonna go through and explain how some of the things are done in here. Starting off, here's the model and the animation. I'm pretty proud of it. It's really smooth. I think it looks really natural. And this is basically achieved with very basic inverse kinematics and some interesting drivers and kind of bone constraints. So I'll go over those in just a second. If we just get rid of this timeline and I make the bones visible, if I go into pose mode, I'm just going to reset everything. And this is just the general default stance of the armature. You can see here that like the foot is in a weird position right now. That's not actually in that position. Blender has this weird thing where if you have a few bone constraints going on at once, it gets kind of confused. So if you reset the angle or position of certain bones, it won't immediately update in the viewport. I could even rotate it and we could see that it looks like the bone isn't in the right position, but it actually is. So I could easily remedy that, I think, by just selecting everything. Yeah, I just press A. And if you know anything about Blender, just tapping A either completely selects everything or deselects. Actually, I think double tapping A does deselection. But obviously, selecting things shouldn't have any effect on the position of the armature. But it did, so it reset the position of that foot there. So this is the actual default stance of it. Strangely, I guess it's slightly below the plane here, but that doesn't actually matter. I'm just going to clean this up a bit so it's easier to look at. I'm going to go over here. I'm going to turn off the floor and the axes, 3D cursor. And now it's just a little bit easier to look at. You can see the origins right here. There's kind of like a hip bone. I could grab that and move it around. The body will follow it. Basically, these kind of hip controls right here are connected to this. So I'll turn on relationships, and you can see that there's a lot of constraints and relationships going on here. These objects here, these bones for the hips, are parented to this middle section here. So you can see the line going straight to it. So no matter where I move this, those will follow. And I can move that within that if I wanted to tighten up the hip area, and it'll still follow that selection. That's very easy. You could do that with, I believe, Control P. Let's see. I can select this bone, shift select the bone I want to connect to, press Control B, and there's keep offset. That'll make sure that it stays connected to it, and it keeps the offset of the position. This is the root bone here. This, if I go into pose mode, this actually just controls the entire armature. So I can move the entire armature around. And things are going to get a little more complicated as we go down the leg. Here is the upper leg bone. There are no constraints attached to it. You could tell that because it's not being changed to any other color. It's not orange, yellow, or green. And the middle bone is exactly the same, but the bottom bone here, the lower leg, has an IK that is leading to the head position of this little foot, which I can move around. And basically, IK is inverse kinematics, and it makes it so that this bone here is pretty much targeting another bone's either head or tail, and you can change that. And what it's trying to do is it's trying to position itself so that it's aiming towards it. And what distinguishes the IK from just a normal dampened track that does the same thing is you could change the chain length here and that shows how much it affects it to these parented bones here. If I change it to 1, it's only selecting the first bone here, and it's trying to basically dampen it to view the position of the target object. If we go and change it to 1, or the next one 2, it's going up another bone in the chain, and that is trying to reach the head of the other bone. So it's constantly going up as you adjust it, and you could do things like create legs or tentacles or hands. So if I have a target set here, and the target is the foot control R, and as we can click this and see that is the foot control R, it's going to try and move to that position. And since it has a chain length that allows it to go all the way at this leg, the entire leg is going to try and achieve that position. And there's again with that weird kind of positional artifact in Blender. Just press A and it fixes itself. It's really dumb. Now the target of the IK, this bone here, foot control R, has its own constraints that I'm going to go over. First of all, it has a floor constraint, and basically what that is you're limiting the location of the bone so that it does not go past the position of another bone in a specific axis. So in this case, it's not going past the floor level bone here in the Z-axis. So no matter how much I grab and try and pull it down, it won't go past. I can go up, but it won't go down. And the second constraint here is it has a dampened track. And basically what that does is it turns an object, and it's basically like the look at function in Unity, where it's trying to position it to look at a specific target. And its target right here is foot angle R, and that is this bone over here. And basically what's happening is this bone is parented to the root of the armature, so it's always staying with the position of the legs. But in that position relative to the IK target, the IK target will move around, and it's kind of copying the position of that foot control, but with an offset. So it's copying it in the Z-axis and the X-axis. And basically, the reason I'm doing that is it's not going to completely shift to the side in the position of that foot, but as that foot moves, it is still dampened tracking to that object. So the way that that's useful is, say that the legs are splayed a bit and they're moving to the side, it kind of automatically places this foot into kind of a braced position. And if that's not a desired result for a scene in the future, I could always just grab this bone in pose mode and move it, and it'll be better. I could do something like that. And the best thing to do with these bone constraints is to kind of implement some kind of automation. And when it comes to something like inverse kinematics, which is probably the most common usage of these bone constraints to automize a system, is that the hand and the arm and everything is moving into a very specific position as to grab something or to move to a target. And you could do that manually. You could bend each limb of the, or each bone in the limb of an armature and do the exact same result, but it would be incredibly meticulous and time consuming, and it would be really silly to do that. So the point of these bone constraints is to automate things, make things easier for the animator or the poser, and as you can see, we're getting that kind of very interesting braced position just by moving it to the side. I don't have to rotate the foot manually. And the leg itself is seems like it's copying that exact same position, because the pole for the IK target, which is right here, basically where the bend in the IK chain is trying to lean towards, that pole is actually parented to that foot control. So as that foot control is dampening to the object behind the foot, it's also moving the pole. So we're getting a very clean, realistic kind of rotation of the leg there. And as we're done talking about the foot, we're going to move on to the most interesting aspect of this armature, and that is this kind of automated system where these toes here, or like manipulators, will kind of curl inward as the foot rises. So if I raise the foot control, the toes actually close up, and we could see that in the animation. And normally you'd manually animate those toes curling inward, but this is something we've achieved with drivers. Now drivers are kind of like constraints, except for you're setting a property relationship between objects in the armature in such a way that it's using values. So as an example, if I grab two bones, I have one bone raising in, say, the z-axis. I could set a driver on the second bone so that as that object is moving in the z-axis, the other bone rotates it. So basically, it's taking a value from the transform of the first bone, or it can even act on itself. So it's taking the value of, say, the position in the z-axis, and it's applying that to the rotation. So as the object increases in its z position by 10, it's rotating the other object 10 degrees. And we could edit those driver values if you press N and you look up to any of these objects up here, these properties, say the Z location, we could right click it. If we're in pose mode, we are in pose mode. Well, I need to be actually holding or selecting an object. There we go. Go right click something like Z location. And I had to stop the video for a second here because Blender's doing another weird thing where normally when you select a bone and you right click on any kind of transformation property or something like that, or even just like an influence for a constraint, usually you can right click it and add a driver or edit drivers, but it's not showing up for me here and I'm not entirely sure why. So if you run into that issue, I'm not sure what to do there. I can copy the driver, but I can't seem to edit it through this menu here. But I did find out that if I go into the object data and I go to the rotation, and this is where the driver is actually stored, rotation X, it should be purple and it should give me an option for the driver, but it gives me an option to add a driver. I can check the drivers in the editor here, and if I double click this effector here, the X quaternion rotation, it'll give me this property here. And the way I'm describing it and the way I have to go in a roundabout way to get to this area here with the driver editor, it's really not that complicated. I wish that it was working in the video now. I guess I could just go into another project and show you, which I guess I'll do. This is bone 1, that's bone 2. So let's try and affect bone 2 with a property from bone 1. If I grab bone 2 and I go to the property settings here, you see we get a lot of transformational property here. And since I'm in edit mode, it's giving me the head and tail. I don't really want to do that. I'm going to go into object mode, or pose mode actually. And we have the individual location and rotation of these objects, or these elements of the objects. We have bone 1 and bone 2. I want to make bone 2 go up. So what I can do is I could find out what is dictating the vertical movement of bone 2, and I believe that's the y-axis. Yeah, so I have the y-axis here, and I believe these are local. I can right click it, I can add a driver. This is what should show up, and what should have showed up in my mech leg setup over there, but it just wasn't. Control D is actually the shortcut. I wonder if there's a shortcut for editing the driver, in which I would say use that if what happened to me happens to you. But I can add a driver, go straight to the screen. You'll see some very simple expressions here. And that's basically, it's established a variable, and I'm going to make it so that when I move this positively in the z-axis, let's move this negatively in the x-axis. So I'll edit this driver. I'll grab the object, which is going to be bone 1, and when bone 1 moves to the left in the x-axis, in local space, it's going to move this up. That should be enough to get us started. So if I grab this, now what should happen is if I move this in the x-axis, this should move as well. And it works. So basically you're comparing properties and using properties to affect others. And it works really nicely, and that's exactly what's happening with the toes on the mech that I have set up. So if we look at it and we look at the drivers, we have a different kind of variable set up here. Instead of it just taking one variable, it's creating one from the distance between two objects. So it's getting the different distance between the foot height variable bone, which I've established, and the foot level bone. So if we go in here and we look at it, there is a foot level bone here, and that is the floor in which the foot controls cannot pass, and we have a foot height variable bone, one assigned to each foot, and that's basically copying the local Y location of that foot. So as this foot moves up, you could see that one is too, and as it moves away from that foot level, you could see it's moving towards and away from that foot level while copying its X and Z location. It is grabbing the variable which is the distance between those two objects. So as it's moving away from this object, that value is increasing, and that value is being applied to the local X rotation of these toes. So as that value increases, these toes will close. And it's very simple and it's very interesting. These are very powerful tools that can do a lot of different things and really opens up a lot of possibilities in animation. And another interesting thing about these drivers is they can be applied to most any values in Blender that are associated with an object, or an element of an object like a bone. Anything that you could see kind of in the inspector can be affected in this way, including shape keys. So you can actually use a driver of a bone associated with a mesh, and you could transition between those shape keys just in the viewport without going to the inspector and changing those values with your keyboard and all that. So hopefully this helps anybody who's interested in this topic. Hopefully it helps the few people who are interested in the Blender subreddit. And I thank you for watching, and I'll see you in the next video. Bye.